let's get started then. Thank you for attending this session. This is the Adventurous Developer's Guide to JVM Languages. My name's Simon Maple. I was in London this morning at Devox UK, and I've got the train across, and I'm very pleased to be here doing this session for you guys. This is who I am. I used to work for IBM for 11 or 12 years. That was a nasty hiss in the front row. Okay, I worked for IBM for 11, 12 years, and I did a lot of product development on Web3 application server. And I did a bit of technical evangelism, and I've since moved now to Zero Turnaround, which is a slightly smaller company to IBM, doing technical evangelism as well. So I come out to conferences like this and speak about cool stuff like JVM Languages. That's not the reason I talked about JVM Languages, though. These are some of the reasons. First of all, I've never created a language before. I've never contributed to a language before, but yeah, for some reason I'm giving an entire talk all around JVM languages. And the reason I'm doing that is because, first of all, I'm a user. Secondly, I love coding. Actually, I just realized that's the wrong way around. First of all, I'm a coder. Secondly, I'm a user. And I like to think of myself as quite adventurous, and I like to try things. I'm an evangelist, I guess. I like to kind of dip my fingers in early on. But it's nice to. I love Java. I've been a Java boy since university, 15 odd years ago. But even now, I still love Java. But it's really great just to try different things, to see what's out there, even if you're not going to use it, just to experience it. So that's me. What would be great is to actually get a quick survey of everyone here, just to see who has heard about some of these languages that we're going to talk about today, and also who has used the different types of languages. So if you could put your hands up for, and this is going to be a stupid one, let's do it the other way around. Who hasn't heard of Java? That's the right answer. Who hasn't used Java? That's the right answer. Okay, now let's move to Groovy. Who has heard of Groovy before? Who hasn't heard of Groovy before? Okay. Who's used Groovy before? So we're looking at probably about 25% of the room. Okay, that's a good start. Who hasn't heard of Scala before? Has anyone really not heard of Scala before? There's someone at the back, isn't there? Okay. Who's used Scala before? Okay, it's probably about 15%. Who's heard of Kotlin? Okay, that's a good number. Who's heard of Ceylon? Oops. Who's heard of Xtend? Okay. Who's heard of Phantom? And who's heard of Clojure? Whoa. Okay, and just some other questions. Who's used Kotlin? One. Do you work for JetBrains? Oh, a red hat dude. You Gavin? No, okay. Who's used Ceylon? Okay. Who's used Xtend? Okay. Who's used Phantom? Ooh, surprisingly few. And who's used Clojure? Okay. Let's turn this back into presentation mode. So this is you. This is the first half is if you've heard of the language, so that's up to here. Second half is if you've used the language. So this is quite different to London. I won't show you London though. It's actually really good to see that none of them are zero really. It's a little bit disappointing to see these numbers here, but hopefully after this session you'll have that initiative to go away and actually play with these languages. So that's you. We're not going to be doing any Hello World examples here. We're doing a slightly more complex, but not too complex, Hello World. We're actually doing a HTTP server example, and all this code for every single one of the languages that we're going to be talking about is available on this GitHub repo. So the slides will be made available later if you want to go to that and actually have a look at our code. Put a whole bunch of forks in, put a whole bunch of pull requests in. We're really keen to get some good code up there. So Java. Here's a great quote. Most people talk about Java, the language, and this may sound odd coming from me, but I could hardly care less. At the core of the Java ecosystem is the JVM. Who thinks they know who said that? Anyone? For a free t-shirt, anyone? So this was said by James Gosling. Oh, you should have said. No t-shirt now. This was said by James Gosling. And I think everyone here is of the similar mindset that Java is a language which loads of people have used, loads of people have got intimate with, whether they like it or not. But really, the core coolness about Java is really the platform it's on, the JVM. So we're not talking necessarily just about Java. We're talking about the JVM. Languages built for the JVM, this is kind of like a showcase of why the JVM is cool. We have a whole bunch of languages that were purposely built for the JVM, not available on other languages, on first creation, or other platforms on first creation. We also have a bunch of languages that were ported to the JVM. So, there are a whole bunch of reasons, including performance, which is why people would like to use the JVM as their platform to base their language on. You also get a whole bunch of freebies. You get garbage collectors. You get loads of stuff like that. It's stuff you don't need to think about because the JVM gives it you for free, and it's been around for about 20 years. So you've got a stable platform to build upon. One of the interesting questions that I like to ask people is, do people think we have too many programming languages out there? It's very, very easy to create language. Well, it's not very easy to create languages. It's easier today to create a language than it was 10 years ago with, tools like Xtext and things like that to actually, give you that first step into creating your language. So it's easier for people to say, well, I don't really particularly like these languages that are already available. Why don't I just create my own? So do you guys think we have too many languages? Hands up if you think we have too many languages. Okay, probably about 5–10%ish. The other side of the coin, of course, is if we try and, what's the problem with having too many languages, first of all? The problem with having too many languages is it disperses the community. And one of the things which makes languages go forward is the community backing behind that and the community support behind that. If we have too many languages, or if the community spread too thinly, we're essentially putting some of those languages at risk, where they may do well if it had a bigger community behind it. The problem of trying to cut languages back, though, is we lose innovation. And a lot of the time, the biggest innovations come from when you start from scratch. You don't have any kind of predetermined thoughts about how you're going to do things. So it's a kind of balance, really. I think hopefully we won't have some graveyard language place where you create a language this year and it'll just be in the graveyard next year, and it's a lot of wasted effort. And these clever guys who are writing these languages could actually be supporting other communities in other languages. But it's interesting. It's interesting to follow and see. I think one day I'm going to work out all the lifetimes of languages and see kind of the distributions of how long languages last. This is what we're covering today, then. Going from some of the more traditional languages that you've heard of, obviously Java, Scala, and Groovy, and some of the more recent ones over the last few years, like Xtend, like Kotlin, like Ceylon, like them. We're going to start at the top, then. This is the history. First of all, came Java back 20 years ago. Scala came out probably about six or so years later, and then Groovy a few years after that. Then Xtend and Clojure came out, and then we've kind of had this bunch of kind of new languages which are coming out, and they're actually really, really interesting languages with a whole bunch of great things that have kind of been taken from existing languages and pulling it into a kind of a sweet spot. So we'll talk about them in detail. This is the introduction of you can see whole bunches of milestones collecting up here just to try and get as much functionality out as possible. And of course, we had the Java drought between version 6 and 7. And then this is I guess, the waterfall where everything just keeps dropping into the later releases. So, let's start with Java 8 then. We're going to take one by one at a time. Java 8, one of the pieces I love about this quote is talking really about the ability that the JVM has to make all languages coexist. I'm sure you've been to talks about polyglot programming and the importance of languages coexisting, but what we're really talking about on the JVM, more often than not, is can this new language coexist with Java? It really all backs down to Java. Can this language interop with existing Java libraries? Because Java has been around 20 years, and Java does have an ecosystem. And the most important thing to do when you're using a new language is to see if you can actually use that same ecosystem, because you've already got a whole bunch of code which is doing all these things. Why reinvent the wheel? We need to reuse these libraries. So there are 3 golden rules for Java, and this is, I guess, important for all languages which have been around and have a community and a following, particularly in industry. The first one is, we don't break binary compatibility when new versions of Java come out. Fairly straightforward. Second one is, we don't introduce source incompatibilities. And this is a really interesting point because when we, things like the collections object in Java, which does need extra methods, there are real problems in trying to introduce new methods into existing interfaces in Java because you break that backwards compatibility. And this has been stopping us up until Java 8. Managing behavioral compatibility changes is the third. So everything may compile, everything may run, but does it do the same thing? And this is what Java has often struggled with going from release to release, and which new languages that have come in have just been able to say, well, I'm going to do whatever I want from scratch. I'm going to learn from the last 20 years of Java, and these are the decisions I'm going to make from the word go. So these are the 2 notable additions in Java 8. Most people in London, where I'm from, didn't get this. This is an old game that I used to play called Defender. Anyone heard of Defender? Whoa, awesome. Maybe it's a French game. So Lambdas and Defender methods are the 2 notable things that we're going to talk about today. We look at Lambdas, and a lot of people who are used to Lambdas and Clojures in other JVM languages will say, well, hang on, this absolutely sucks. Why are we being restricted so much in our usage of Lambdas in Java 8? The reason is because, the restriction in Java 8 is that if you want to use a Lambda, you have to use a single abstract method, a SAM type. It's exactly what it says. It's going to be an interface which only has one abstract method. A couple of examples: runnable and comparator. So you have a run method, you have a compare method. There are no other abstract methods on that interface. Your Lambdas, when constructed, will effectively be in place of that single abstract method. We also have a Java util function package. This is a new package with a whole bunch of annotations. It's actually been done in quite a complex way to try and make things simpler, I think. There's one annotation called functional interface, and that's an annotation which you would put on your interface to say, all it does is say to your compiler, I want you to treat this as if it is a functional interface, and therefore it does its static checking on that functional interface to say, do you have only one abstract method? If you don't, like in this case, you'll actually get an exception thrown at compile time. But one way around that is to use this default keyword. And what this default keyword does is allow you to add an implementation. This is if you use Scala traits. It's quite similar to that, where you can have an interface with implementation. Now that looks great. That looks very, very useful, very, very interesting. The reason it's interesting is because, as we were talking about before, we don't want to break those 3 golden rules in Java. Here's an example of a collection but this is Groovy code, by the way. This is an example of a collection where we call each on that collection. So we grab every single item in that collection, and we simply do a println. If we wanted to do that in Java 7 or below, we'd have to use it as a collection in a for, iterate over each item in that list, and then we'd have to print out every single item. And the reason we have to do that is because iterators aren't very good, or in this case, the iterable interface isn't very good. It only has a single method called iterator, which gets you an iterator back. But what we would love is a for each method, so that we can run similar code here and actually say, I'm going to run for each on a collection, passing in a lambda. So what we have here is a default method. And by making a change to this iterable interface with a default method, we are not breaking any pre-existing code, because by making this change to an interface now, we do not rely upon people who are implementing our interface to also add that method. Because if you want to override the method, you can. If you don't, then you don't have to. So now we can make changes. This is the power of the Defender method now. We can make changes to existing interfaces which people rely on to provide more value add with a default implementation, and the implementer can get that value. They won't necessarily use that value straight away, but they don't have to change their source to migrate up. So that's a real key point. This is what we'll be able to write in Java 8 now. List.forEach, and then we're passing in here a new little way of writing systemout.println, which is we can do that because we only have one item that we're passing in. So, we're making Java 8, beyond Project Coin and things like that. We're making it a lot more. The guys are making it, loads more readable and much, much nicer. There's a lot less boilerplate. So that's what we're going to talk about for Java 8. For Scala and Groovy, we're going to give it kind of overviews because these are the kind of more well-known languages. And then we're going to talk in a little bit more depth about some of the newer versions. So is Martin here in the room today? I was sitting next to him in the speaker's room, but I couldn't see him here. Okay, so I wanted to ask Martin a question, actually. He said in this quote that Scala's a small language, and by the time Java 8 is out, Scala will be much smaller than Java. And I wanted to know whether that was because he thinks Java is going to get a lot bigger, or whether he thinks Scala is going to get a lot smaller. But hey, we'll ask. Scala is one of those languages that, depending on your approach to Scala, if you can see the deep end or if you can see the shallow end, you'll like it or love it or hate it. Because if you know where that shallow end is and you approach Scala in a certain way where you do small tasks at a time, you don't jump into the full complexity, that's typically how people enjoy and make use of Scala. People who jump into the deep end and use things like the simple build tool, which I think, has anyone used the simple build tool? It's quite an ironically named tool, I think. But simple build. If you've used Scalas as well with a Z, anyone used Scalas with a Z? No? Awesome. Don't. Oh, there's one hand there. Stop using Scalas. They're very, very complicated pieces, and if you jump into it straight away, I think it's one of those things whereby there's such a gap between Java and Scala in those areas. That's why people consider it as massively overcomplicated. So we'll start talking about the companion class. This is one of the big differences between Java and Scala. The companion class really separates out object instances and class instances. So you can have, if you had a class variable, that would actually sit on the companion object, and you'd actually have to import this new companion object if you wanted to use those kind of static class types. Anything which was an instance variable of a class would sit in your class. So straight away you've got two different compilation units, I guess. The Scala syntax is very, very nice, and it's quite similar to a lot of the languages that we're going to be talking about today. There seems to be kind of the Java where everything's huge words and massive boilerplate, massive amounts of real estate on your screen, and then you find the other languages where instead of using public static, we just use var and val. And val is a value, so this is effectively a final variable, and var is your usual mutable variable. Cases are fun, but the real thing I wanted to talk about on this slide is the named and default values. Who's used named and default values before? A few people. Do you think that? Keep your hand up if you think they're absolutely awful. No, exactly. They should be in every single language that exists today, named in default values. It's such a simple thing. All it is when you create your method, you give each parameter a name. You could potentially give each parameter a value as well, and that will be the default value if you don't pass that in when you invoke your method. But when you actually invoke your method, you can actually put names by your parameters so that it makes it so much clearer to read. How many times have you had a method with true, true, false, true, true, false, true, false, and like the third true is delete this account or something, and you think, oh, hang on, which one do I have to change? And then you read it across. This just makes it so much simpler. It's just, when I use named and default values, it's just beautiful. I just love using named and default values. And it really annoys me to go back to Java when it doesn't have them. String interpolation is another lovely thing about Scala. You can embed Scala code into your strings. So really, really simply with a little s before this triple double quote, which essentially means we're going to be using a multi-line string here. And once you have that s there, you can actually embed Scala code directly into your text. And this is really, really nice, just to view, because you can actually see the output you're going to get, pretty much. You don't have any like plus to add this, what that, and you can't really see it. But this is much, much nicer to view in code. Scala also deals with null pointer exceptions slightly differently, in that you have an option type. And this option type, this here is the return value for this method call. And this option type is effectively saying what we could do is return a null from this method. We might not, but we might return a null, so you should be wary of that and code around it. We can return two types from this, a sum or a none type, and they're both of type option as well. If it's of type none, we're basically saying don't try and dereference this because it's going to be a world of pain. If it's of type sum, you can get a value out. So they're return values as well, and we haven't got a return statement. Wow, crazy. The reason is because in Scala, everything's an expression, and every code block has effectively a return value in it because it's the last expression in that code block. So here, the return value for this code block here and here is return value of get content type, and that's going to be assigned to content type. So everything in Scala is an expression. So let's nip into Groovy now before we go into the new languages. So Groovy has sweet spots beyond what Java will ever offer. I think that's an interesting line. I think that can be used with quite a lot of different languages because essentially Java is turning into this kind of really stable platform whereby everyone else does the cool stuff, and then about 5 years later, Java says, actually, yeah, that is pretty cool, let's pull that in. And don't get me wrong, I'm a big Java fan, I love Java. But unfortunately, it is always going to be 5 years behind, 10 years behind, and I don't see that changing in any time soon. Groovy is Java Supercharged, though. It kind of tries to stay fairly similar to the Java design, but it has nice things, like here we have the question mark dots, so that we're effectively checking for a null every time we do a question mark dot on a dereference. In this case, if either the address is null, we're actually not going to run that line at all, so the street name won't get assigned. Also, ternary operators, if username, do this, otherwise anonymous. There's no point in having those two, so we just block it down into this little quiffy Elvis character here, dude. It's just more readable, it's just nicer, it's Java but without boilerplate. And we also have a whole bunch of other things, interpolated strings, default parameters, and a REPL, which we're going to talk about later as well. So yeah, Java Supercharged. We also have cool closures, and really, really simple, straightforward closures, which are not really bound in the same way Java is. Really simple example, square equals closure item times item. And then all you need to do is pass that into a collection, invoke the square method on that collection, and you get back a really nice list. Really simple code, really small amount without any boilerplate. Collections, again, absolutely beautiful to read, beautiful to write. Can't really say much about this. We have a collection, we do a println out that, we get a really nice printed collection. If we wanted to run a filter on a collection, we can do that with a simple closure here. If the item.size is less than 3, include the item in short names, and then we're reduced down to all the names with 3 or less characters. So really, really straightforward code, really simple and really, really nice on the eye. In version 2 of Groovy allowed you to have static type checking, static checking on your code. So for some reason, and this is one of the things, who likes dynamic checking and static checking? Who prefers static checking? Who prefers dynamic checking? And what's your vote? Both. Who likes both? Hey, okay, that's quite a few. So here, if some method doesn't exist, which in this case it obviously doesn't, you'd get an exception. If print line name doesn't exist, you'd get an exception. Straightforward things in Groovy. The magic occurs because we have the @type checked annotation. If you don't have that @type checked annotation, you'll be effectively using dynamic. There are also a couple of other nice things where we can actually do type checking on assignments, also type checking on return statements to make sure that we're being nice to the language. But there are a couple of instances, or there is an instance like this one, which it doesn't actually catch, so it's not entirely foolproof, but it goes some of the way. In this case, we have a list of strings, and we're actually trying to perform an integer operator on it. Okay, Phantom. A lot of people think Phantom is one of these languages which are dying. Did anyone use Phantom years ago that are still not that have decided not to anymore, or no? So Phantom puts first-class functions and closures into many of its standard APIs, and really puts functions high up on its agenda. And I think this is very, very common to many languages other than Java, I guess. You can run it in two different. You can run Phantom in 2 different ways. You can run it as a script, or you can run it as a kind of a module. If you're running it as a script, very, very nice and easy. This is kind of a little hello worldish, which I promised I guess I wouldn't do. But you can run that as a script, and it will run absolutely fine. You can also run pods, and pods are cool because code modularity is built in. In this pod, we're effectively saying, I'm going to write a module. This is my version. This is my name of my module. I'm making this module unique. And I'm going to depend, I need to use all these other modules, or all these other pods at different version. And anything which has code modularity built in for me is awesome. I'm also an OSGI kind of fan as well. So this is good. Java interop, fairly straightforward as well. We have Phantom code on the left, we have Java types on the right, and we have some magic in the middle where we just have some nice libraries where we can call to effectively do that type management for us from the Java world into the Phantom world. Concurrency. When we tried to do our HTTP server, we got it way wrong. We tried to create a server actor from an actor pool and then send an object to that actor. As a result, we needed to, because the thing that we're sending has to be immutable, we needed to run something called unsafe, or create the unsafe object. This isn't Java unsafe, this is some Phantom unsafe. And as a result then, we cast it back to unsafe on the way out, and then grab the value out of that. Oh yes, also this is a funky thing in the language where the question mark might be null, and we'll also see this in many other languages. So we're effectively saying we may receive something, we may receive a message, but we may not. Then the boss, Andy Frank, the creator of Phantom, saw our code and said, no, you can't use unsafe, it's an absolute last resort, what are you doing? Which we said, okay, what should we do? And we got this code back, and this is way nicer. So thanks very much, Andy, if you're watching. This is much nicer. You just simply pass the socket on the constructor. Why didn't we do that? But hey. Okay, functions and closures. Again, very simple. Here's an inline closure. One other nice thing is the 100 dot times, where you can actually effectively call much nicer methods on these kind of more primitive types. Other things like Groovy and things like that will also support that. But again, functions, closures, really easy, really straightforward, no fuss. Strings can also look like Scala in the fact that you can actually embed phantom code directly into it, so you can see more likely what you're actually going to get out, rather than just a whole bunch of pluses and a whole bunch of double quotes. And now let's talk about Clojure. Clojure is very, very similar to Lisp. It takes a whole bunch out of Lisp, it takes a whole bunch out of C#, obviously takes something out of Java, which is kind of where the name Clojure came from. It has a REPL, which is the read eval print loop, and this is absolutely awesome for people who haven't used them before. For many other developers who, like, whether you're a Python user, a Perl user, or a Groovy user, you already know about this, and this is like something which has been done for many, many years. But for people who haven't used it, it's a really rapid way of making changes, seeing your results, without having to do massive amounts of recompiling and things like that. When we use something like Clojure, we needed to be, when we did our HTTP server example, we needed to stay true to the language, which is really staying true to the functional principles. And I'm a very object-oriented person. The last time I did functional coding was like in university, so this kind of hurt me slightly. But the idea is, some of the functional principles is that code should have little or no effect to the surrounding code. Global variables shouldn't really exist. If you call a function with the same parameters, it should do the same thing every single time and give you the same result every single time. And yeah, this is some Clojure code, and this is where my object-oriented eyes just started hurting. Any Clojure users? Who are the Clojure users here? I'm sure there were more of you putting your hand up before I slated it. But no, I mean, it's. The language is rock solid. The language is cool. It's just from my point of view, going from something to another. It's like me as an Eclipse user trying to use IntelliJ, and it's like someone from IntelliJ trying to use Eclipse. It's what you're used to. It's very, very hard to switch. Yeah, this is a what the function moment when I started looking into this. There are a lot of interesting points here whereby creating new objects, calling new methods. It's very much talking about reading left to right almost. I want to call this method on this object, passing in this. It's kind of nice to read. It's just a very, very different way of doing it. In the same way, I guess there are a lot of French speakers here. When you try and learn French from English or try and learn English from French, a lot of the words, like when you talk about a color, you use the word at the end rather than at the start, where it's very, very different. So it's a different mindset, really. Java interoperability is really easy. You can have Clojure imports, where you just put a require for a Clojure, for a Clojure package or a Clojure object. You can have a Java import, where you just import the package and then a number of objects in that package or a number of classes in that package. We also had to say, okay, we're going to do this functionally. And a couple of changes that we had to make. The key part here, I don't know if you can see that at the back, the key part here is this part here. Whereas before, we kind of used a string tokenizer, and every time you call a string tokenizer, you're effectively getting a different result. And that goes against the functional principle, because every time we call a function, we want to get the same result back every time. So what we're effectively doing is doing line splits in a kind of rotary fashion, so that we're not calling it with the same arguments and getting different results out. So this was a kind of one of the changes that we had to make, but it's not really so much about the code. It's just more about the way of approaching the language. Concurrency, we could have actually used atoms or agents, which are the natural, I guess, native concurrency modules in Clojure. But what we wanted to do here was just show you how easy it was to use concurrency just by doing Java interoperability. So all we're doing here is just creating a new Java thread, nothing else to do, and then we just pass in the client socket as part of the function. So very, very neat, very, very easy to call Java code directly from Clojure. Oh yeah, and Clojure loves its brackets, so I think it should actually be called bracket Lojure. because it kind of looks like Clojure, but it stays a little bit truer to its nature. Now, Ceylon. So are you you're a Red Hat employee, are you? You are? Do you work on Ceylon? Okay, so shall I be nice? We actually did enjoy working with Ceylon actually very much. One of the parts one of the quotes that we got from Gavin King is here. And as much as I love Java, I did actually smile at this because I thought, that's not actually setting the bar very high, is it? We don't want to make a worse language than Java. But yeah, okay. So Ceylon's built by Red Hat. Red Hat build JBoss. JBoss introduced the modules framework, which is a kind of OSGI light environment, which allows you to do modularity, similar to OSGI, but without the kind of services model on top of that. Ceylon kind of uses the same approach in the sense that modularity is built in again. This is, again, an awesome thing. Here we've got a module which we've coded. The module's called com.zt. The version's 100. We can also say what other modules we want to use, what other imports we want. Code modularity is awesome, so that was one of the big ticks for Ceylon for us. Run is main. Not much else to say about that. Compilation outputs are very, very interesting. I might ask you a question about this later, because I'm not sure whether I like this part of Ceylon or not, in the sense that where you create different variables, different methods, you actually get different compilation outputs. So in this case, we're actually getting a compilation output just for the port variable here, and we're getting a compilation output for the method as well. So we're actually, in effect, in one source file, getting a whole bunch of different compilation outputs. I'm not sure why that is, but I don't know. I personally just think it's a little bit, you get a little bit too much for your money there. Java interop. Oh, yes, I just realized one slide, which is going to be funny. Java interop, okay. So, to use Java interop, first you need to do an import. That's a java.base at version 7. Second thing you need to do is use Java. One of the points here is what Ceylon does is if you try and use something like get output stream on a socket, what Ceylon does is it says, if that's a getter, what you actually want is the output stream. So we will just actually give you a method which is .output stream. So it's almost as if you're actually getting the field directly. There's also a bit of type conversion that you may need to use just to bridge between the Ceylon and Java types. So this is the problem we had when we actually coded the HTTP server and ran. We got a null pointer exception, and we thought, okay, this should be nice and easy to fix. It's a null pointer exception on classes.ceylon line 19. So that's this line, a buffered reader.read line. That's really easy to debug. The only thing that can be null is the buffered reader, but no, the buffered reader was not null, and we got a null pointer exception from that line. The reason is because we needed to add a question mark onto this string, because at some point we were getting a null back from read line, and there was additional Ceylon code which was added, which tried to look at the result, and it was the Ceylon code which was actually null pointering. And there's a smart guy in Zero Turnaround called Anton Arapov who did a whole bunch of bytecode checking to actually understand what it was doing under the covers and see which actual line was failing. And it turned out it was a bug, and we've raised that with the Ceylon guys, and I'm not sure if that's been fixed now or not. But the workaround for us, we actually every time we wanted to do something like this, we'd need to check if it was null or not. The whole process, was a bit meh, and really it was more because there was little feedback we were getting out of it, but in terms of what the problem was, because at first view, the problem should have been fairly easy to work out, but it just wasn't. That was the only problem that we saw with Ceylon. Everything else we loved, I promise. Kotlin is a really nice programming language, actually, from the JetBrains team. Now, the JetBrains team, anyone from JetBrains here? No, the JetBrains team is the team that worked on IntelliJ, and they've seen many, many languages go by, and they said, okay, we think we can do better than these languages because we want to kind of cherry pick some of the best parts of each language. A lot of people say it's very, very Scala-like. I think it takes an amount from each of the languages. One of the things that Kotlin bases itself on is the fact that Java has a big ecosystem. Java has a large number of libraries which it wants users to make use of, and it doesn't want to hinder that at all. So one of the interoperability methods in it is effectively trying to make that as simple as possible. So here's some nice code snippets. When, as, and is. When is effectively a Java switch statement. Is effectively an instance of statement. And as is effectively a cast. The difference is, in our switch statement here, we can actually run stuff against this stream. So what we're saying is, if the stream is of type reader, then call close on the reader object. And what we're effectively doing here is, the is has turned into an implicit cast. So we're saying, if the stream is of type reader, then cast it to type reader, and do what you want, run what you want to run on it afterwards. So it's really, really nice. Less boilerplate again. Parameter naming, we've talked about this already. We have default values in our method descriptions. We have parameter names, much easier to call. And we have a sneaky function literal in there as well. We also have, this is the invocation of that, where we can actually say that these are the parameters which I'm passing in, and this is the string value, or sorry, in these cases, these are the string values which I want to put through, so that if you're looking at it, from cold eyes, you can actually see exactly what you're passing in. We also have defaults because we're not passing in everything that we need to for the method call. We actually use defaults which are passed in on construction of in the signature of the method. And what we'd actually do in Java in this case, I guess, is we'd have two methods, one with 6 methods, and one with 4 methods. And you call the method which has 4 methods, and then that calls the method which has 6 methods with 2 defaults. So this is just losing all that boilerplate, and it's just way, way nicer. Every language should have it. We also pass in a neat little inline closure there, or inline function there to that method call. Null safety is quite similar to some of the other languages, whereby you use a question mark on your type to state whether your variable is nullable or not nullable. In this case, in the first case, we are saying that this variable a is a string, and it will always be a string. It can't be null, and if you try and assign null to it, you're going to get a static error. You're going to get a compilation error. If you do the same with a type of string question mark, what you're saying is this variable b, it could be a string, but it could be null. So the compiler won't actually let you dereference item b without checking if it's null or not first. You can do that perfectly fine with variable a, because we've stated when we created it that variable a cannot be null. What we have to do is we have to dereference it with the question mark dot, which effectively says this may be null, it may not be null. If it is null, then don't run that line. Don't assign value l to that the b dot length to that value l. So it just literally won't get run. Functions, very, very simple again. This one, what we're actually doing is we're overloading the integer object, and we're effectively doing an absolute. So now if we actually just call number, we get -1. If we call number.absolute, we get 1. And that number is actually of type int. So it's a neat way of doing extensions, effectively, on your existing methods or existing objects. And this brings us actually nicely onto the final language which we can talk about. It's called Xtend. And Xtend is quite subtly different to many of the languages that we've talked about today. What Xtend does is it actually translates the Xtend code into Java code. It generates Java code for you. Whereas the other languages actually compile down into bytecode that the JVM reads. So our hello world, this isn't a hello world, this is a Gangnam style hello world. So we print line, the class is called Oppa, by the way. We print line Gangnam Style. What we're actually doing is when we compile this, we don't compile it into bytecode, we compile it into generated Java code first, and you'll notice there are a couple of things. First of all, we're actually using a different object here to do our system out println. This is a Kotlin object. I'm not sure why they decided to use that, whether that was for performance or something else. The other thing you'll notice is that it's about 3 times the size in characters. It's just, I don't know, it pains me to say it, but Java's just so behind. Okay, let's be fair to it. That's generated code. Okay, but still. We have rich XML in Kotlin in the sense that where you do your multi-line XML or multi-line strings, you can actually push in variables into your strings. So again, no need for the double quotes plus blah blah blah. You can just read it more naturally. Also, Socket doesn't have a send HTTP response method. And this is where Xtend actually comes into its own a little bit, because Xtend was so named because you can extend existing objects very, very easily. And the way you effectively do it, I'm actually doing it in this method definition here. Because here we have a method called send_HTML response, and the first value, the first parameter we're passing in is a socket type. What we're doing as well is we're actually creating a method, or we're effectively creating a method called send_HTML response on the socket object as well, because the socket object is the first parameter we're passing in. So we have an equivalent method like this called send_HTTP response. And because we have the socket as the first parameter, we can call it very, very nicely from socket.send_HTTP response. It reads so much nicer. Xtend syntax, again, this is really just to kind of show how, well, 2 things here. First of all, how much more verbose Java is, and also inferred types, which is also quite customary of some of the other languages that we've talked about. We don't need to say the type of this, because we're assigning it. This is a string. The compiler knows that's a string. It's not stupid. So we don't need something here to say it's a string. In this case, we do, because we're not making an assignment. But yeah, it's much neater. So in summary, functions are first-class citizens. That seems to be one of the big trends throughout all the languages. Statically typed languages seems to be kind of the higher, when people are creating new languages now, typically they're creating statically typed languages. If you'd have asked that same question 15 years ago, it would have been dynamic languages. If you ask the same question in 15 years' time, it'll probably be back to dynamic languages, but we won't know. Java syntax isn't very good, unfortunately. Yes, it's 20 years old, it looks 20 years old, but hopefully with some of the new defender methods, some of the nice new things, we're actually going to see more and more readable code. The JVM does rock. The JVM's awesome. The JVM's going to outlive every language currently on it today, and it's just awesome. There are loads of languages out there, not just Java, not just Scala, not just Groovy, but those would be the 3 that if you leave here and want to actually start learning some other languages, really have a look at those languages, and look at some of the new and up-and-coming languages, the Ceylons, the Kotlins, and the Xtends, which are really actually producing. When we were coding with them, it was a really, really beautiful experience just to write code, because it made coding fun. It's not annoying. It's not verbose. And be adventurous. So hopefully, some of you are going to be going away now, wanting to look into it, wanting to do a bit of coding. This is who you are now. Everyone knows about every language. Everyone has heard about every language. So we can hopefully get the other graph up as well. All of this information is on REPL Labs. This is part of the Zero Turnaround website. It's entirely free to get non-commercial, non-product information about a whole bunch of stuff, including continuous delivery, productivity reports, and this entire series on Adventurous Developer's Guide to JVM Languages. I think I'm pretty much out of time.
You're right.
I'm out of time. So
if you have questions, just ask them to outside.
Yeah, so just come and grab me if you've got any questions.
A cup of wine and some cheese.
Okay, awesome. Thank you very much. I hope you did enjoy the presentation. If you thought it was 60 minutes wasted, this is our zero turnaround plug. We do something called JREPL, which is awesome for Java developers because it wipes out redeploys and saves you absolutely huge amounts of time, about five weeks in the year. So go and try JREPL, and if you didn't like the presentation, you can redeem your time there. Thank you very much. Cheers.